This video was produced in conjunction with the Science Path Project, a joint project with the School District of Palm Beach County, Palm Beach State College, and funded by the Quantums. What do you know about direct and inverse variation? Not too much? Well, the mystery is about to be revealed, and it will make you very happy. Let's start with some scary word problems. Have you ever been taking a test and you see this written on the page? Y varies directly as X. Or exposure time varies directly as the candle power. Or Y varies inversely as X. Or intensity of radiation varies inversely as the square of the word problems. Oh, everybody hates word problems. But it really isn't so bad. We're going to talk about direct and inverse variation today. Take a moment to commit these two equations to memory. And we can talk about what each one of these equations mean. K in each case is a constant, and a constant can be any value that does not change. There's your K, and there's your constant. Both of these equations show a relationship between two variables. Remember, in mathematics is all about relationships and patterns. How do these variables relate so that the constant stays the same? That is the big question. Let's start with direct variation and use an example to explain it. Let's use the equation y over x is 24. So we've just chosen that value 24, just kind of pulled it out of the air, and that's okay. But that is going to be our constant, that's going to be our k. And let's use a table of values to kind of find out what happens to the two variables as we change one of them. As we change x to 2, y has to become 48 in order for y over x to remain the constant 24. If x is 4, y is 72. If x is 8, y is 192. So you can see, if we take a look at what's happening to the x, we've multiplied the x by 2 each time. And when we multiply the x by 2 each time, we also have to multiply y by 2. So the same thing is happening to both sides. Both x and y change by the same factor. In this case, the factor is 2. So that brings us to the golden rule of direct variation. Whatever you do to x, do also unto y. We can write this direct variation as y over x equals k, or the equivalent equation, if we multiply both sides by x, is y equals kx. You can use either one of those. If you memorize one, you can find the other one from what you've memorized. Now let's look at inverse variation. And once again, let's use an example. xy equals 24. And let's say, do the same thing. Let's choose some values for x and find out what happens to y. So when x is 1, y is 24. When x is 2, y is 12. When x is 4, y is 6. When x is 8, y is 3. So what we did with the x's is we doubled them each time, and when we doubled the x's, the resultant y is, to move from the first y to the second y to the third y, is divide by 2. Or we could say multiply by 1/2, because remember, dividing by 2 is the same thing as multiplying by 1/2. So if we multiply one side by 2 and divide the other side by 2, these are inverse operations. Hence we have inverse variation. And we can represent this equation by x times y equals k, or y equals k over x. Once again, they're equivalent. You can use either one of them. You can memorize them that way, or memorize both of them. Let's look at some word problems. And I know word problems, once again, are your favorites, but just knowing what direct and indirect variation is doesn't do you much good in chemistry unless you can actually apply it. So in a chemistry experiment, the mass of a sample varies directly as its volume. The constant of variation is the density. Write an equation that models the experiment. Well, first of all, let's go back through this and pick out some of the things that we know. We know mass is going to be m, and that varies directly as its volume, v, and the constant is the density. And we're talking about varying directly. So our equation is going to be mass divided by volume is density. So now we have our equation. Let's put it to some use. Find the density of a material given that 5.03 gram sample occupies 3.24 milliliters. So we have our equation once again, and all we have to do now is we're going to plug in 5.03 for m and 3.24 for our volume, and we get 1.55 grams per milliliter. So once again, to recap it, take a look at your equation, find your variables. It says direct variation. Write your equation, then plug in your values. Let's take a look at what the graph of a direct variation will look like. And let's use an example again, and this time I'm going to use y equals 2x. So if I set up my table of values and I choose values for x between -2 and +2 and plug them into our equation, we're going to get our values from -4 to 4 for y. And if we graph these, you can see that they line up and they go right through the origin. So there's our straight line, linear. Direct variation is linear. And if we take a look at the slope, we're going up 2 over 1, up 2 over 1, up 2 over 1. So up 2 over 1, or up 2 to the right 1, is 2 over 1, which is 2. So that means our slope is 2. Aha, slope. Remember, slope-intercept form is y equals mx plus b. In our case, in this example, we go through the origin, so b is 0, so it's going to be y equals mx. If we know that m is 2, then y equals 2x, and bingo, look what happens. Slope is the constant of variation. Once again, slope is the constant of variation. That's real important to remember. Direct variation is linear, and the slope is the constant of variation. M and K are the same things. Okay, so let's take a look at the graph of inverse variation. This is going to be a little different. If we use the example y equals 2 divided by x, and we want to make up a table, we have to be a little careful, because in this case, x cannot be 0. So let's first choose some values, 1, 2, 3, 4, 5, and find out what we get. Okay? So if x is 1, y is 2. If x is 2, y is 1, and then we have some fractions. So as x is increasing, y is decreasing. And if we put some of these values in here, and then go back and fill in our table for values between 1 and 0, I'm going to go backwards to 1/2 and 1/3. I also get when x is 1/2, y is 4, and when x is 1/3, y is 6. So I have that graph. Now, most of the time, if you're working in real life situations, real world problems, you're going to be graphing in the first quadrant. But let's take a look at what happens if we add the negative values of x, we get the negative values of y, and we have the graph is also in the third quadrant, and that's from a purely mathematical standpoint. Let's look at some, well, before we go on, the graph of the inverse variation is a curve. The graph of direct variation is a line. So now let's look at the chemistry connection. For direct variation, remember that's also called, we could also call that proportional. We have mass over volume is density. We have volume over temperature is a constant. That's Charles's law. We have pressure over temperature is a constant, which is Gay-Lussac's law. And for indirect variation, one example would be pressure times volume is a constant, and that's Boyle's law. So now you know all about variation, and it's a mystery no more. Now go work some problems.